Okay. So for the next part, we're going to take a look at modules, a couple of data structures in Python, and object-oriented programming. So we are not going to have time to go very in depth for all of them, but I gave you some resources in the links that I gave you, which you can take a look at and read more for each of these in there. So first of all, the most important thing probably in Python is its modules. And it's one of the reasons that Python is so popular these days, and it's the most popular programming language in the world. The thing is, modules are blocks of code, are packages, libraries, and these are the things we call them in other programming languages. We say, for example, libraries or stuff like that. So these are parts of code written by someone else that are made available to you. So you can use those in your projects. So for example, we have modules that do numerical computation, matrix manipulation, and for example, image processing, stuff like that. You can use each of those and very easily. So what Python has is something called PyPy, which is the Python package index. My internet connection is a little bit slow, but it should get the work done. Yeah, it says Python package index. So what happens is that, for example, imagine you've done a project and you want to make your code available to the world so that anyone can use this. What you would do is that you would structure your code in a particular way and then upload it on this website, Python package index, or what they call PyPy. And this comes with a tool called pip. So if I do conda and list, okay, let me change the font here. Okay, can you see the? No, it's small, right? Let's make this like a 36. Okay, so I can call pip install and a name of a package. So for example, as I said, we have packages for numerical computing. One of them is NumPy. I can write just pip install NumPy here, and then it will automatically install it for me. So what it says right now is that requirement already satisfied. It's because I already have NumPy on my laptop. If I didn't have NumPy, it would just grab it and install it for me. I didn't need to do anything else. For example, in C, you would have to link the library, create the shared object scope, and do a lot of stuff to get this working, but that's all you need in Python. And then if I, for example, say import NumPy in my project, I'm going to talk more about how we can import, but this is one example. It's going to import that package and I can use it afterwards. Yes?
Can you see the source code of any function?
Yes, you can see the source code of all of these packages that are here. These are all open source. So, for example, here, if I say, let me find where it is installed. Okay, so this is in this location, ML workshop. If I just open this location, everything that you install comes into this path inside lib, I guess. Numbers are library. Somewhere around here. Yeah. I'm not sure where, but it goes inside there. Other than that, you can search NumPy here. And for example, this is it, and I can download files. And this wheel is something like a zip file, and then you can extract it. Look at the code inside. So they're all open source. In addition, most of the open source projects here have their home pages. And inside there, you can find their GitHub repository URL, and inside that, you can see all the code. You can also change that. You can install, you can fork their GitHub repository if you're familiar with GitHub and Git in total. You can fork their repository, change their code, and install that instead of installing the default package. Yes? I'm going to get to that in a bit. Okay. So modules are one of the main reasons Python is so popular, because it's so easy to install libraries that are written by other people and use them. And whatever you're doing, you can probably find a very good Python package that you can install and use, either if you're doing game development, web development, whatever you want to do. There are packages out there that do that very well for you. Other than that, data structures you've probably seen are things like arrays, dictionaries, like hash tables, stuff like that. If you're not familiar with them, it's probably because you don't need them a lot. But for example, creating websites or doing something very heavy computing stuff, you would have to use them to be efficient. So here we have a package. Let me open up. It's called feeble. And this is how you import another library inside your code. You say import and then the name of the library. So when I say import feeble, it means there is a package called feeble. Go ahead, import that for me so that I can use its functions and all the code inside it. So where is feeble? Here we have a file called feeble.py. So here I have just defined a couple of functions, and one of them will return the Fibonacci series up to a value, and another one will just print it. It doesn't return anything. So if I run this code, it will run the feeble2 function for me. So look at it. I say feeble.feeb2 and then give it an argument of 100. What happens is that it says, okay, I have a package called feeble. Because it is not something I have installed with pip, it's going to assume it's either a folder or a file, probably. So it's a file here in this case called feeble.py. It will go and import everything in that file for us inside this like a special variable, which is a package called feeble. And then all the functions you have inside the other Python file are available here. You just have to call feeble dot and then the name of the function. Now imagine I do not know what kind of functions this package has. I want to get a list of those functions. We have a special function called dir, directory. So if you call this, it's going to give you a list of the names of functions that are inside that package. So when I execute this here, you see that I have a few, I have feed and feed2, but I also have some other like objects inside this package. So as I said, everything in Python is an object. So functions are objects inside this. There are also special objects like the doc that we have seen, which is the doc string for the whole file in this case. And we also have some other objects. So for example, name is the name of this package, which is feeble here. We also have version, which is a standard format to save the version of the package that the user is using. So here I printed two of those special variables. As I said, they start with 2 underscores and end with 2 underscores. Again, everything is an object in Python. So I can say, for example, some variable equals feeble.feeble. So some variable is the name of my variable. It's going to be assigned with that function. And then I can just call that variable. So if you have done programming in other languages, this could be a bit confusing, but as I said, everything here is an object. So we can put functions inside an object, pass them to other functions, or return them, or stuff like that. We have a very good library, comes in handy sometimes, called math. So here I'm showing you how to import only one function from the library, from a package. Here we have a module called math. I want to import only the function sqrt, which calculates the square root of whatever I pass to it. So when I want to do that, I say from math, this is the name of the module, and then import sqrt. So when you import the whole library, all of it is going to be stored in your RAM, and that's going to take space. So for example, math is not a very large library, but if you import larger libraries, it could be up to like 1 gigabyte, which is going to consume a lot of RAM. But what if you only want to use one function? This is how you would do that. You say from math, import sqrt. And then here I calculated the square root of 16. Yes. Okay. So if you have coded in other programming languages, we have objects. And we can pass them around. We can pass an object to a function or whatever. So the thing in Python is that even functions are objects. So I don't know if that makes sense to you, but if you have done programming, for example, in C, objects and functions are very different things. In C++, for example. But here, functions are special objects. So I can assign a function to a variable. I can say A equals a function. So here I set some variable equals, and then I address the function. Equal.feeble. If I put parentheses here, it will call this function, but that's not what we want to do. We want to grab the function itself. So I will not call the function. I will grab the function itself and put it in a variable called some variable. Okay? don't declare variables in Python, so you can put anything inside a variable. So, for example, let me show you another function. For example, I say a equals 10, and I print a function called type, and I pass a to it. It will show me what is the type of this variable a. So I assign 10 to a, and right now it's an integer. So if I say a equals 10.5 and then print the type again, at first it was an integer, but then I assign another value to it, which is a float, and automatically you see the formatting has changed. And then I could also change it to a string. It's converted to a string. I give it this function name, feeble.feeb. It will be a function, but if I call this for like 100, it is a non-type because feeb does not return anything. feeb2 returns a list. Okay. So something else we could do, as you saw, if I wanted to call a function from the feeble package, I had to say feeble dot the name of the function. What if I don't want to do that? I can say from feeble import star, which means everything. Which means I want to be able to call the name of every function in this package without specifying feeble dot in the beginning. So previously I had to call feeble.feeb. I had to write it like this. Now I can just say feeb. I don't need to add the feeble dot in the beginning. You could also do something else. For example, you could say from math import sqrt as s. Change the name. And then say s of 16, which is 4. So with as, you can change the name. So you can say import feeble as f, and then say f dot anything inside that package. Yes?
So what's the difference between modules and packages?
Same thing. Sorry, I use them interchangeably, but it's the same thing.
They are all the same.
Packages, modules, libraries, yeah, same thing. Okay, sorry.
With the package or whatever, I have to install it first on my desktop before using it.
Yes. Yeah. So every package that you want to use, you have to first install it. Say pip install the name of the package.
And this is why I asked you to return.
Yeah. Oh, sorry. Let's get back to that. So you come here, you say pip install, and then the name of the package. For example, SciPy is a scientific computing package. I press enter. Again, it's already satisfied in my laptop. Let's find something that is not. Let's say pip install Flask.
How to get the name of this package?
Okay. You would have to search it online. One way is to just search, for example, web development in Python, for example. And it will give you a list of different packages and comparisons, stuff like that. You can find those online. But if you know what you're looking for, you can just search it in the PyPy website. So here we have a search as well. But mostly you would have to do some digging and then search internet. What packages do people use for this specific problem? and find the best one yourself. Yes?
So using the import function, if the file you're trying to import, like for feeble, for example, is in a folder that's in the directory, so how would you tell import to look into that folder?
Okay. So the question is, imagine I have a file inside another folder in my computer, and then I want to import the file in that other folder. What happens then? So we have something called pythonpath. Are you familiar with environment variables?
No.
Okay, so environment variables are some special variables that we have inside here without specifying it exactly. So for example, imagine, let's say I can come here and in system properties I have something called environment variables. Okay, so these are some special variables that I can be used inside the code that I write in my command prompt. So here you could set up something called pythonpath. Yeah, I don't have it inside here, but in Windows that would be, I'm not sure what that is in Windows. I have to use Ubuntu. Sorry. I mostly use Linux, and yeah, we have something called Windows Subsystem Linux, which is something easy to use. So if I say echo and then Python path and $sign in front of it, and it's Python underline path. Python path. Yeah. If you just search Python path, it's a special environment variable. And when you could give it a list of different locations on your hard drive, and it will automatically import everything in those locations. So you specify the folder, the main folder in there. You will also have subfolders that are going to be imported automatically. For those, you would have to put a file, a special file called init__.py. And I'm going to talk about that as well, not much into depth, but here is the example that I said. __init__.py. And you have to format this in a specific way, and you can import it from everywhere in your computer afterwards. I have a couple of good references on the website. One of them is swaroop.com, and inside there it's an online book for learning Python, and you can look at object-oriented programming and modules and how to set up modules. What are the ways that you can import them from other folders and stuff like that.
Yeah, but like you can't just have like a Python script and you say like import and then the address?
No, that's not possible. You have to add it to Python path. And then when you say import this name, it will automatically look into the Python path environment variable that you have. Actually, when we do pip install, what it does, it downloads the package, puts the code in a folder. I was trying to find it, I couldn't find it. I will show it to you later on. And it will put it inside a folder. It will add that folder to Python path. And then when you say import this package name, it will do that for you. Yes?
So when you install NumPy in will it automatically reflect on the
Yes. When you install it, after you have activated the environment. So remember we said we do conda activate the name of the environment. So imagine you have two projects on your laptop. One of them needs Python 3.6 one of them is Python 2.7. And this comes up a lot because some packages have not migrated to Python 3. So you have two projects, one of them is Python 2, one of them is Python 3. You can have two different environments. So what you do is you activate one of the environments, it will automatically bring up everything you installed in that environment, and it will bring up the Python version that you wanted for that specific task. So, for example, you said conda activate project B, and it will go to project B and bring up everything you have already installed in there, bring up the Python version that you have specified in there, and then it will be usable for you.
So for this one, you have to go to command prompt, just to control activity.
Yes. So here I can say conda env list. It means list the environments in my anaconda. So here you see I have quite a few environments for Python. So for example, I use this one to code serverless computing applications. I use this one for reinforcement learning and artificial intelligence. I use another one for machine learning. And I have different packages installed in those. I have different versions of Python in those. So each time I only want to work on one of these. So I say conda activate that environment's name. And then it will bring up that environment for me, set everything up. And then if I install a package in that environment, and my Jupyter is running in that environment, then everything is accessible in Jupyter. Okay, questions? Okay, let's move on. Let's take a look at a couple of data structures. So the first one is something like what we had in arrays. It's like an array, it's called a list. But the difference, as I said, is that you can put any different types of variables inside a list. But for example, in C, Java, C++, programming languages like that, every element in the array should be of the same type. But here we don't have that restriction. Yes?
Just to make sure that let's assume that I have two packages, one works with 3.7 or 3.6 and one with 3.8.
Yeah.
And do I have to install both components, the two versions?
You install conda, you create two environments. The command is like conda and create, and then you say -n the name of the environment, then you say the version of Python that you want to use. So I can say conda and create -n my new environment, which is its name, and then Python equals 3.7.
Okay, so under conda I can use both versions of Python.
Yeah, so you create two environments. One of them has Python 3.6, for example, another one has Python 2.7. And then I can use them separately for different projects. Okay? So, we have some special functions for lists. One of them is len. Len of list gives you the length of that array. So for example, here we have shop list equals 4 different things. If I print it out, it will say I have 4 items to purchase, which is 1, 2, 3, 4. Now imagine I want to print those objects that are inside my list. I can do it with a for loop easily. I say for the name of the variable in the name of the array. So the first time that this for loop is going to be executed, item is equal to apple, the first element in our array. So it will set the value of item to Apple and run the block of code inside the for loop. So that block of code right now just prints it. And then it will set the second value mango to the variable item and run this block of code again. And it goes on and on. So if I look at the output, it will say these items are apple, mango, carrot, and banana. You could also you could also put \n for line break, go to next line, \t to go one tab further, or every other thing that you have used elsewhere. So for example, you could use \r to go to the beginning of the line you're at. We can use this function called append to add something to an array. So the arrays are not fixed in length here, they're variable length. So you can just say shoplist.append something else, and it will add that to the end of the array that we had here. So after this, my shopping list is apple, mango, carrot, banana, and rice. It is appended to the end of the array. I could also do sort on arrays. And for example, for strings, it will sort them alphabetically. For integers, it will sort them by value. So I can say array.sort, and if you look at it, it's A, B, C, alphabetically sorted here. This is how we index arrays. You say bracket and the index inside. So Python is 0 indexed, MATLAB is 1 indexed, meaning that arrays in MATLAB start from 1. So you say 1, 2, 3. In Python it's 0, 1, 2. It starts from 0. So it's like Java or C in that matter. So I could assign this to a new variable, say old item equals shoplist bracket 0. This is how we delete an object from the array. You say del, del, and then shoplist 0. It will delete the first item in our shopping list. And then I can just write this again, and you see that apple is not there anymore. Okay, yep.
The sort and the append, it seems that they are functions. And why we just use the sort and the function?
So as I said, everything in Python is an object. So list is a special object. You say, for example, shoplist.append. It means that this object has a function called append. And then you call that function, it will automatically append it to that.
We define our own function. Actually, we define a function.
Okay.
So we can use also the function.
What do you mean, for example?
For example, in the last example, we learned how to define a function.
Okay. Yeah. Yeah, so for example, you can create objects and have functions inside the object. I will talk about it a bit later on. So one of the examples is list. It's an object. It has a function called append. But there are other special functions like len, which is not inside any which is not inside an object. It's a like a special function defined in Python. So, as I said, we saw this earlier in return. When we return more than one item, they're returned as a tuple, which is like an array, but not exactly like an array. The difference is that a tuple is not going to be changed after it is created. So when you create an array, you give it a list of variables. They are all inside that array. You can say array of 0 and then index inside that array. It's just like the same thing. But in arrays, you can change each of the values later on. In tuples, you cannot. That's the only difference. And you usually use this from when you get the return and there are more than one variables there. Again, the special function len works here as well. It gives you the length of that tuple. And you can either define it like this with parentheses, or like what we use to return. Just have them comma separated and then return the value. So again, len works here. And if I run this, I can have a tuple which has a tuple inside it. So when I say new zoo 2, it's like new zoo is this one, 0, 1, 2. This is zoo. And then this will be zoo. And then when we interpret it as zoo of 2, it will be 0, 1, 2, and it will be penguin. So you can put whatever you want inside the tuple. You can put arrays inside the tuple. You can put tuples inside the tuple, whatever variable you want. Yes? Not exactly appending. When you append something to an array, the length of the array is larger. But here, the length of the new zoo is 3. So we have 3 elements inside them, but one of those elements is another tuple. So it's a tuple inside the tuple, and you can the main point here is that you can put anything you want inside the tuple. There are no restrictions.
Tuple means array?
Tuple, as I said, is something like an array. The only difference is that you cannot change the values after it is created. Yes, and when you return more than one variable, it's returned as a tuple. So something else that you can use, as we have seen when we return values, is that I can say here, as you see, new zoo has 3 variables inside it. I can say ABC equals new zoo, and it will automatically assign the first variable, which is monkey, to A. So if I say print A, it will be monkey. And the rest is just like what we saw with the return with more than one variable. Yes?
So C will become a tuple. Will C become a tuple?
C becomes a tuple, yeah. If I print C, it's the zoo variable. So it's a tuple. So dictionaries are hash tables, if you're familiar with them. So what it basically is that you give it a key. So for example, students have some documentation in the university. We have a student IDs. And with only knowing that a student ID, they can retrieve all the information about us. So a student ID is like a key here. So you put a student ID in, and what you get is everything about that student. So here it's defined like this. You give it, you start it with curly brackets, and then key, colon, whatever you want here. So, for example, the keys could be student IDs, and the value inside could be everything about us. So it could be a tuple of everything they know about us. For example, first name, last name, grade, stuff like that. So what hash tables are a data structure that can be accessed very fast. So for example, if you put everything inside an array and you're looking for a specific student, you will have to go read the elements inside that array one by one. And if you have like 1 million students you want to search through, for example, all the students in Canada, you will have to go look at the values one by one. But this is a special data structure that finds the values very fast. So it will compute a hash and then go to the memory address very fast. It's not something you would use normally. Just know that if you use this, it's going to retrieve those informations very fast for you. This is how we index dictionaries. So you say the name of the dictionary, and then inside here you give it the key. And this key could be any type of variable. So for example, I could create a dictionary like this. And then say 1 is high, and then 2 is by. So these are different types of keys. This one is an integer, this one is a string. But it doesn't matter. Whatever variable, I can put it in here, and whenever I say MD of 1, it will say hi. And when I say MD of a string 2, it will say bye. Yes?
Can I have a tuple or a list within the dictionary? Can you repeat that? Can I have like a tuple or a list inside the dictionary? Can I have like a list?
Yeah. So you can put a dictionary inside the list, you can put a list inside the dictionary, because each of the elements of the dictionary or a list is an object, and it doesn't matter what it is. So one member of this dictionary could be a function, another member could be a list, something like that. So for example, I can say my list, and then my list, and then say 1, 2, 3. And then when I say MD of my list, it will be this 1, 2, 3 that I put in here. I could also set another dictionary inside here. So I could say something like this, and then I can reference it. So it's a dictionary inside the dictionary, so you can put anything you want inside the dictionary.
So how do I like put down like in the just like the student now key like the ID?
Yeah.
So with that key I get every information. But now I only want to know path.
So for example, imagine if I say the students and then give it a student ID, it gives me a tuple, for example, and then I can reference inside that tuple. So for example, my student 158 blah blah blah, and then I say now give me the name, which is like the second parameter in my tuple, or give me his family name, give me his GPA, something like that. Here's something else we could do. We could check if a key exists in a dictionary. We could say if and then key in the name of the dictionary. So you don't know if someone's student ID is correct or not. you can say if the student ID in all the students, then grab it. If it's not, you can say error. You didn't input the right student ID. So there are different ways to retrieve an element from a list. As I said before, you could just give it the index inside the bracket. You could also do like -1. If you say mylist -1, -1 it means the last element. So you could also do it like mylist length of the array -2. It would be the same. But you could make it easily like this and then say -1, and it will retrieve the last element for you. So for example, imagine I say A is 1, 2, 3, 4. I want to retrieve the last element. One way is to do print A of length of A -1. It would be the last element that we have here. Another way is to just write -1. It is the same thing. Then if I say -2, it is one before that. So second to last. You could also do it like, let's make a bit larger list of range of 1 and 11, which will be from 1 to 10. Then say, first of all, a -2 is 9. I could say a 3 to 5. Again, it starts with the index 3. It's a 0 indexed array, so it's 0, 1, 2, and then index, and then 3, which is 4 here. Let me change that to start from 0. Okay, so when I say, let's print A as well. So this is A. I say A3 all the way, but not including 2, all the way to 5, but not including 5. So it's 3 and 4. I could also say from 2 to 9. It starts from the second one, the index 2, which is, since it's a 0 index, it's the third one. And then it goes all the way to 9, but not including index 9. So what it does, it will print for you A of 2, A of 3, all the way to A of 8. It doesn't include the 9th one. You could also say from 2 to the end. If I don't put anything after the colon, it will be from 2 until the end of the array. I could say colon 3. It means start from beginning. I didn't put anything before the colon. Go all the way to 3, but don't include the index 3. I could say colon colon -1. So the third one is the increment that you give it. So for example, if I put 1, it's the whole array. It means start from the beginning, since I didn't put anything here, go until the end, I didn't put anything here, and increment by 1 each time. I could say increment by 2. As you see, it's 0, 2, 4, 6. It's skipping 1 each time. And if I say like -2, it will start from the last one, which is 9, go back 2 items each time. Okay, any questions so far? Okay, we have another object. This is not very important. It's a set. Can anyone tell me the difference between a set and an array? In a set, every element has to appear only once. So if you say set of 1, 1, 2, you only have 2 values inside that set. It will automatically remove the extra 1. So like set of 1, 1, 2, it means there are only these 2 distinct values inside this set. We also have other functions to manipulate the strings. For example, we have a function called starts with. It checks if the string starts with the thing that you passed with. So for example, if the string starts with SWA, it will return true. If not, it will return false. I can say if A in this string, if this is inside the other string, it will return true, otherwise false. Find gives us the position that the string is found. For example, if I say A equals hi, my name is Neil. A dot find my gives me 4. This means this is index 0, 1, 2, 3. So M is the index 4. It means the word you're looking for starts at index 4. But if I put something that does not appear in my text, for example, my dash is not in my text, it will give me -1. So we could also use this to search in a text, search in a string. We also have a special function called join. And you can say, for example, imagine we have an array. A is 1, 2, 3, 4. And the default format for printing this array is like this. But imagine I want to put a star in between the values inside that array. So I want to write 1 star 2 star 3, something like that. I can say the delimiter I want to use, which is a star in this case, and then dot join A. Expected instance. Oh, these should be a string. So you want to grab some strings inside the list and then put them in one large string with some delimiter. You can use it like this. I could also use this for putting like line breaks between them, or like put 2 line breaks in here. So it's just for formatting and creating a beautiful output. So this gets us to object-oriented programming. So we saw some data structures. Lists are something like arrays, which is a list of different variables. Then we have dictionaries. Dictionaries have keys and values, and they retrieve the values very fast. So if you have a large list, you're looking for a specific thing, it will take a lot of time, but if you have a dictionary, it will grab it faster for you. Then after that, we saw set, which is something like a list, but you only store distinct values inside it. You don't like keep the duplicates. So if you want to see what words appear in a special text, you can just put them in a set, and it will automatically delete the duplicates for you and give you the distinct words that appear in that text. We could also have, like I mentioned, dictionaries, and there are different ways to grab a subset of the list. There are ways to change the ordering of the list. So this will become handy if you want to manipulate them. So object-oriented programming. In object-oriented programming, this is just created to help us reuse our code, create something that is easy to use. So for example, you can have a very complicated object, but when you want to use it, it's very simple to use. And it's doing all the things that need to be done inside that object, and you are not aware of it, you are not handling it, it will automatically do it for you. So this is how we define objects. We say the keyword class and then the name of the object, followed by a colon. Again, the scope of the object is shown with indents. So here I have an indent, which means everything that is in that indent will be inside the class. So what if I want to create an empty class? If I say class person colon and nothing else, it will give me an error. It will say I was looking for something with an indent here. So print hi, it will say indentation error. So I have to put something in here, but if I just want to create an empty class, I can press put pass here. It means that right now I do not want to put anything in here, but read the rest of this code as something that is out of this object. Then after you create an object, you can instantiate the object. This is an instance of that class. So you can have a class called student, which has different parameters, has name, family name, and student ID, has GPA, grades, stuff like that. And these are all inside the object student. And then we create an instance of a student, which is, for example, an example student there. And you give it values that it needs. So for example, in our case, could be first name, last name, and all the information about the student. And then it will create that object. If I print it, it will show me something like this by default. Underscore underscore main underscore underscore is just saying that this is not inside another module. This is just defined here, so it's inside this block of code that I'm reading. If I define this inside feeble, it could be feeble.person, so something like that. So we can have functions inside object. So again, we define it like def, say hi, and then we can pass in arguments there. We have a special variable here called self. So self is all the characteristic specific to that instance. So for example, if this was a student, self was the instance of that example student. So for example, self could be Nima inside the function that is instantiated with my information. So here I can say P is the person, and then P dot say hi. Oh, it just says hello, how are you? It doesn't use self. Okay. So we could define a specific function here called init. Yeah.
Just think like so it's somehow have this so.
Yes. I'm not sure how many of you are familiar with like Java or C++, but you have two types of functions. One that is general, so it's just like any other function that we use. It's not specific to an object, but it's inside the class. So I can say, let's say diff say by, and then just print by. So this one is specific for one instance, but this is for a class. Now, if I want to call these, for this I have to instantiate the object. So I have to say p equals person, just create an object of type person, and then I have to run it for that specific person. But if I want to call this one, I can say person dot say by. So this executes that function, but I do not need to instantiate, create an instance from that object. It's just a function that is inside the class. It's just a normal function. So usually what you would do is, for example, give general functions that do not need the specifications of one instance in this shape, and then, for example, if I want to have the name of the person in this object, and when I call this automatically it will use their name, and that would be an instance, an object called by an instance. Yes? Yeah, it's like a variable that is passed to the function automatically. So I did not specify it here, but when I said p dot, it means that it will automatically pass the p variable inside the self in there. So here self would be p automatically. So another way I could call this function is to say person dot say hi and pass in p. These two are equal. You see? So this is equal to this one. As I said, if I don't put self, it will be a class of function. It cannot use the specifications of that person, for example. So imagine you have a class called animal, and then you have 10 different instances. One of them is a cow, one of them is a gorilla or something. So if I have the self, I can use, for example, like make a sound, and if it's a cow, make one sound. If it's a gorilla, it will make another sound. But if I don't pass the self, it does not know which animal it is. It's just a function in the class animal in total, in general, not a special animal. So if this is a bit hard to follow, you can use the references and learn more about object-oriented programming. And right now, I'm assuming you're familiar with it in different languages. I'm just trying to give you the syntax in Python, but you can use online courses to learn more about them. Okay, so if you've done object-oriented programming in other languages, and they have special functions called constructors and destructors. So when you instantiate a new object, it will automatically call its constructor. So then inside there you can do different things. For example, I created a function, I have a function in it here. This is my constructor. And it gets the self and name. And it sets self.name equals name. Now, what happens is when I create person, for example, let's put in Nima here. So self is auto-generated and passed to the function. Now I give it another variable, which is a string, and its value is Nima. So name becomes Nima. Now self.name is set to what we pass to the function. So when I say p.name afterwards, it will be what I pass to it. So this is how you can access a variable inside an object. And you can set it in the init method. I could also have a default value here. So it's just like any other function. And I could also like set self.age equals 11. So doesn't matter what you pass in, it will create another variable inside that object with the value 11. So the thing is, we use functions to make our lives easier. We use functions to do something under the hood without knowing exactly what's going on in there. So, for example, imagine that we want to keep tabs on the number of robots. And whenever a new one is created, we want to add it to the population. Whenever one of them breaks down, we want to remove that from the population. We could have a class robot, have a variable inside it called population. The default is 0. So when we create the object, it will be 0. And then we give it a name. And then we say robot.population plus equals 1. So this is a class variable, not a variable specific to one instance. So then whenever I init a new object, it will be created and it will add the population by 1, increment it by 1, and then whenever I call the function die, it will decrement by 1, or if it is 0, it will say this was the last one. We could also have class methods like this. So these are called decorators. And you can specify special functions. If I didn't add this decorator here, which says this is a class method, the default would be this would be self. But I want something different. I want to be able to change the value in a class in general. So I understand that for those of you who don't have previous experience with object-oriented programming, this is a bit hard, but try to learn it. Go read the references that I have given you, and then look at the code again. Now I want to move a bit fast because we don't have much time, and I want to get to the projects for this module. So we also have inheritance, but you can read about it later on in the references. So here we want to do a couple of simple projects again. The first one is a guessing game. It's something similar to what we did earlier, but this time, each time we want to set the number randomly. So this is where you would use import, and you can use a library called random, and it has a function called randint. It will generate a random integer for you between 2 and 6, including 2 and 6. And then you can set a number randomly and then ask the user to, and then they should try to guess that number. Any questions about this mini project? Yeah. So they have to be specific. Okay, so let's try to do this together. So first of all, we need to create a random number which will hold what we want the user to guess. So let's say my num equals random.rand int 2 and 6. But before that, I need to import random. So I say import random, and here if I print my num, it would be the number that I generated randomly. So what is the next thing that we need to do? Ask user for a guess. So for the next part, we say, for example, guess equals, if I do like, what is your guess? and then print that guess. 2. So it will get the user's input and print it out for me. So if I get the type of this guess, as if you remember, when we get an input from the user, the type is a string. So we have an integer and we have a string, and we want to compare them. So for example, if the user says 3, as you see, this is of class string. So I'm gonna have to convert this to an integer to be able to see if it's larger than the value we had in mind or smaller or something like that. So we say something like this, int of this value. Then we have to put if else in there. Check if it's larger, equal, or not. So I could say if my num equals guess, print correct. And then what else do I have to check? If it's not equal, I will have to check if it's larger or smaller. What can I use here? Else, or for example elif, because I want to say else, which means that they are not equal, but if it is, for example, smaller. So if I say elif here, elif guess smaller than my num, print you guessed low, for example. So it will be if they're equal, so correct. That's what we're going to print. If not, else, if it's smaller, you say you guessed low. And then else, so if it's not equal, if it's not smaller, it should be larger. And then you can say else, print you guessed high. So let's run this. What is your guess? Let's say 3. I guessed low. But the application is done here. But what we want to do is keep asking the user for different guesses. So if I say, for example, running equals true, and I can add while running. So as long as running variable is equal to true, I'm going to keep asking the user for their guess, but my number is constant here. So the user has different chances to guess it right. I could also do something else. Let's say write while true, and whenever they guessed it correctly, whenever they guessed it correctly, I can say break, which means it's going to break out of this loop and it's not going to ask again. So let's see if it works like we want it to. Between 2 and 6, let's say 2. I guessed low. 3, no. 7, high. 5, still low, so it should be 6, and it says correct. And then it stops there because we break out of this loop. So in solutions, we have a bit more complicated one. You can also say exit, which means they give up, they don't want to continue, and we give them a certain number of tries. Oh, it's in the second one, for example. Yeah, we print how many tries they did before finding the right answer.
How do you indent set of lines?
Oh, and when you select the like 3-4 lines and then press tab, it will indent them. When you press shift tab, it will indent them backward. So
Second question is, how do you see what like see the random number? Because for the iteration,
okay. We have a function random set seed Python. We have a function in random library, the random library called seed. You give it a value and it will set the seed for the random generator. So it can be repeated, it can be like done again with the same order of random numbers. If you just search random seed, it will give you examples for that. Here, random.seed initials internal state of random number generator. Okay. So let's move on to the more advanced project here. So in the second project, we want to create our own strong password generator. So it's going to generate a random sequence of characters, numbers, and like exclusion, exclamation points, and stuff like that. Exclamation marks. Oh, sorry. So we can do. Here's a couple of hints. So you can use random.choice, and it will choose one of the members of the list you give it, or one character of the string that you give it. So you could give it a string containing like A, B, C, D all the way to Z, and then give it numbers, punctuations, whatever you want to be used in your password generator, and it will pick one of them randomly. And then you want to like create a strong password with length like 10, 12. So you use that as well, and try to write a function that does this. And in addition, here are a couple of things you could use. For example, if I say a string dot ASCII characters, ASCII letters. Oh, sorry, I have to import a string first. These are all the ASCII letters, which is like ABCD and capital ABCD. Also, we have digits and punctuations. In addition, if we want to concatenate two arrays, so say A is equal to 1, 2, 3, B is 7, 8, 9, I can say A plus B. So this will grab those two lists and concatenate them together. So we can create a very large list of all the different letters and stuff like that, or we can like combine these strings and then pick a character randomly from them, and then repeat this like 10 times, and it will create a very strong password for us. So in C programming, we have something and then we go with that, you can create like inputs, you also make games. Also, right now it's much easier than creating websites. Yeah, so for example, there's and these are the blocks of content code. And so it's just relying on it and to handle everything for them. So if you want to object to be able to use it. Right now, better research sites have faster websites. What I think is about websites, does object recognition and you send the image to that functions will give you and create like lots of videos very easily Just grab Oh, yeah. Yes. No. It's going to be random. Yeah. See. Each time. You're on the recording. Okay, so let's try this one together. So let's say all characters that appear in our password, we want to put them in one large string. So let's say a string.ascii letters plus string.digits plus string.punctuation. And then if I print this out, it will be a very large string including everything I want to appear in my password. Now let's say I want to create a function which gets the length of the password and gives you the password. So let's say def generate genpass, which means generate password, and then length equals 10. I give it a default value. So what I want to do is that for I in range length, for length number of times I want to grab one of those characters and put it inside my string. So I can create a password like my pass. It's empty in the beginning, but I put one random character inside it one by one. So I say my pass plus equals, which means is equal to my pass plus, and then random.choice from all the characters possible, and then in the end return my pass. And I can do print genpass, which is a function. Then if we call it length 4, for example, it will create a password of length 4 for us. If I want the length to be 12, this is 12 characters. So this is how we can generate a random password I could also like have a variable length, pick that randomly as well, anything you want.
In this case, it's possible to, for example, have a 4-digit password which contains all small letters.
Yeah, for example, whatever you want to use inside your password, you can like have constraint there, just add some characters inside your all chars, objects, variable. You can also like remove a couple of them. So there are ways to like do simple tasks very in one line in Python. So one of them is, for example, I have exceptions array, and I want to remove like semicolon and dot from there. I could do something like this. So, and then what I did is like I put together like 10-12 lines all together in one line, and you don't need to learn this right now. This is like when you're more comfortable with Python and you want to do things faster with fewer lines of code. But what I did is that I created an array. So this is like create an array. I have brackets here. In here I say I for, so what I want to put inside that array is I. For I in all chars. So it will iterate through all chars. And then I want to put I here only if I not in exceptions. So I went through all of them, the ones that are not inside exceptions, I put it in an array. And then I want to create a string based on that array. So I do empty delimiter, and if you remember we had join before, and whatever you put inside here, it will put it between elements in there. So I don't want to put anything between those, so empty delimiter dot join in that array. It created an array for me, and it just removed semicolon and dot. So yeah, there are ways to do things faster in Python. We also have some special functions called lambda functions, which is like a function in one line. So it's something like this. It's a like whole function in just one line, and most of the time it's used when you want to pass a function to another function. So as I said, if you have a very large data and you want to like do language processing on all of it or machine learning on all of it, you put your code inside the function, and it will distribute your code between different computers and grab the results. Something like that, yeah. So the last project is going to take a bit more time, and since we don't have much time right now, we cannot go through this. The last one is just a simple hangman. So I have a word list.txt in there. It will grab a word randomly. You see how we can do that. We have a like wildcard called words. Inside there we have a function called getRandomWord. It will grab a random word for you, and then you can let the user play hangman. The solution is in there. Try it out at home, and then when you're done, take a look at the solution. It is like a more advanced project, but we don't have much time right now, so I can't go through the solution. So right now until 6 o'clock I will be here if you have any questions. So I will just be here if anyone is. Thank you very much. Thanks for coming today. And I hope you learned something that you can use in your career later on.
Okay. Hello everyone. My name is Milad, one of the executive members of MEGSA. I would like to thank each and every one of you for taking the time to participate in this workshop. I would also like to extend my appreciation and sincere thanks to Mr. Mahmoudi. As a sign of appreciation, we have got very small gift that I would like to give to Mr. Mahmoudi. He participated in this workshop on a voluntary basis, which is greatly appreciated by MEGSA. Please join me in thanking Mr. Mahmoudi by a big round of applause. The other thing is that we will send you a survey shortly, so please provide us with your valuable and precious comments. If you have any questions or any comments for the MEGSA executive team, or for example, you have any concerns about the next programs that we have, for example, if there is any program or software that you would like to participate in the next workshops, please let us know. Based on the number of requests that we will receive, we will try our best based on the resources that we have to organize other workshops and similar sessions. Thank you one more time very much for your time and attention and participation. Thanks very much.
That's right.
The environment.
Thank you very much.
You are very welcome.
So how do I, because I
Okay, so you don't need the binder anymore. First of all, have you downloaded the GitHub repository onto your laptop?
what is it?
The URL that they gave you, GitHub repository. bit.ly/pyMEGSA.
No.
Okay, go there. .ly/pyMEGSA MEGSA. L1.
Yeah, I took it.
Just copy this.
No, I want to, because I have some other projects, like websites, applications, so it's helpful.
Okay, great to hear that.
Okay, now download this. Download, click that, and down.
Okay,
So first you have to download this. Okay, now extract it somewhere.
Yeah, it was
Okay. Now go to Now you see this is where we are right now. This is the path. So this CD2 was it on desktop? And then the CD2 and then you run that line of code that I have it here. So conduct, create. You copy it, paste this code, and it will create the environment for you.
Okay, for the Jupyter, so
Yeah.
any stuff I import.
Yeah.
Okay. One last thing I noticed is sometimes when I try to run, it doesn't run. So
if you look here, this is okay, so currently it's running.
but anytime it doesn't run, what
And one reason could be since this is on my binder and this is on the cloud, and they have like limited resources because this is like for free.
Okay.
And after half an hour that you don't do anything here, they will kill authority
Okay.
to free up some space.
Okay.
So then if you run it, doesn't happen, it doesn't work.
Yeah.
So what you have to do is launch the binder again.
Okay.
So click on that link again, it will create a new one for you. But if you run it on your laptop, you're not going to have this issue.
Yeah, sure, because it's using my laptop.
Because it's using your laptop.
Yeah. All right, thank you so much.
Yeah, thank you. Just a quick one. Well, I think I'll